Problem 18, Bullseye matrix. So the statement is, given n, which is always odd, return the output A that has consecutive rings of the numbers 1 through n plus 1 over 2 around the center point. Examples, and we're given an input of n equals 3, and we get that the output A is a 3 by 3 matrix with 1 in the center and is surrounded by 2's. Then when the input is 5, we get that A is a 5 by 5 matrix with 1 on the center and is surrounded by 2's, and all this is surrounded by 3's. So we can get the idea of this problem, like a bullseye. Also, here we have some examples of other cases. When the input is 1, you just get use a number, use a 1 on the matrix, and then when the input is 7, it's a 7 by 7 matrix. And we can see that it's the same idea, but we need to find the relations here. So the first thing that we can think is that at the center, the coordinates are the input plus 1 over 2 on the column, and for the row is the same, the input plus 1 over 2. So if the input is 7, the 7 plus 1 over 2 is 4. So the central number, the 1, is going to be on the 4th column and on the 4th row. And then we can like work around that. Another way to make this problem is just to keep overreading the matrix. And that's the way I'm going to make it. So first, I'm going to make the matrix to be all 4's. Then I'm just going to make the inner matrix here, from here to here, to be all 3's. Then I'm going to override those values with 2's, and then at the center is going to be a 1. Let's try to make it. Let's see how I can make this. So, okay, this is kind of interesting. Let me think how I can make this. First, we need to call a number or the parameter. Let's see, W. Or no, maybe better is like an S. S is going to be n plus 1 over 2 in parentheses. So that's the first thing we need to know. And then also I'm going to call F, which is going to be n. I just want to have it, I want to work with an F right now. While F is bigger than 1, what are we going to make? Let's say that our answer is A. It's going to be full of zeros of n. So we are creating an n by n matrix of zeros. Okay. Now we want to override that with S, right? Yeah, for sure. So for I equals 1 through n or to F, for J, no, for I, for also I equals 1 through F, A, I. That doesn't have too much sense, isn't it? Yeah, it doesn't have too much sense. How we can make this work? J equals S. And we end it. And after the iteration, we have to make S equal S minus 1. And also F equal F minus 1. Let me think. It should be greater or equal than 1. So this ends when the number is 0. Yeah, something weird is happening here. Let me think. It shouldn't be 1, isn't it? it should be other number like a counter. Make a counter, isn't it? Equals 1. And then we work with counters. And then we make counter increase for each iteration. I guess that's the answer. I'm not sure actually. Let me see. So first we're starting with this number. For example, if n is equal 5, then s is 3, and then it's not f, isn't it? It has to be s. S. Yeah, we're working with s. When s is bigger than this value, we are overwriting the matrix. Okay, I think this is correct, so I'm gonna send it and let's see if there is some mistake here. No, that's it. So the way I made it is I was overwriting the matrix. So first it was full of 4s. For example, 4, 4, 4, 4, 4, all the way down, like that. And then full of 3s, 3, 3, 3, 3, 3. And yeah, all the way down until here, So yeah, I keep changing the value of s. S at first was, for example, 4, and then after the first iteration, I change it to 3 and also change the indices. So for example, first was counter equals to 1, but after the first iteration, counter is now 2, and we are starting in the second column and the second row, and we are getting into f. But f also changed. So now it was not the 7th column, but the second to last column, and the second to last row. So yeah, that's why I'm making it override the way I make it, the way I want it. So yeah, the iteration keeps going until s is equal to 0. So that's the way I make it.